This is Lab 1 charge tapes. A material can become charged by acquiring an excess or deficiency of negative charge from other objects. In this lab, transparent packing tape is charged, and the interactions by the tapes on the tapes and on other objects are observed to determine how much excess charge is on one piece. The materials are listed. In order to form a charged tape, we'll form two pieces of tape to have a handle as pictured and put one sticky side down on top of the other. We're going to quickly pull the top U-tape off and stick it onto the edge of a table. If we bring our hand close and we see any interactions, we can see if it is charged or not. We predicted that if two U-tapes were brought close to each other, they would attract, and we found that the tapes did attract. When neutral objects were placed near the tape attracted as well. If a U-tape is positively charged and a charged plastic pen is also positively charged, they will repel. If the pen is negatively charged, they will attract. If the U-tape is negatively charged, we'll find the same but opposite as above. A neutral U-tape will attract to a charged plastic pen. We find that the U-tape from our experiment is negatively charged by rubbing a clear plastic pen on cloth to determine the sign of the charge. Two U-tapes can be utilized to float by balancing gravitational and electrical forces as shown below. We can make two simplifying assumptions to idealize these tapes for analysis. First, we can assume that each U-tape has the same net charge, and second, we can treat each tape as if all of its charge were located at a single point at the center of the tape. The length of one of our pieces is 0.22 meters, and we find that the mass of this piece will be 0.22 grams. We can use this mass value to determine the magnitude of the gravitational force on tape B, and by measuring the separation distance at which tape B begins to float, we can determine the charge on tape B and the corresponding number of electrons excess on tape B as well. We can also determine the number of atoms on the sticky surface of the tape, and then ultimately find the ratio of the number of excess electrons to the number of atoms as a whole. From our computational model, we find that our charge is approximately the same as that as calculated by hand. Assumptions to find the amount of charge on the floating tape in this computational model was we ignored air resistance on a moving object and we treated the tape as if it was a point charge as said before. Since electrons are negatively charged and protons are positively charged, if these signs of these charges were reversed, we would find that most of our observations would be the same, as opposite signs would still attract and same signs would still repel. It was important to handle the charged tapes as little as possible when conducting this experiment because we found that as these charged tapes came into contact, the charges would be stripped and transferred onto our hands and other objects. The glow script code is shown.